Have you ever looked up at the night sky, a vast expanse of darkness sprinkled with twinkling lights, and felt a sense of awe and wonder? The universe, in its immensity and mystery, has captivated humanity for millennia. We gaze at the stars and ponder our place within this grand cosmic tapestry. Are we significant or merely insignificant specks in the grand scheme of existence? This fundamental question leads us to a profound paradox. You are nothing, yet you are everything. And yet, this paradox holds within it a deep truth, a truth that we will explore on our journey through the cosmos.
Imagine the Big Bang, when our universe burst forth from a singularity some 13.8 billion years ago. Space and time came into existence, and the universe began its rapid expansion, cooling as it went. Energy coalesced into matter, forming the first particles, the building blocks of everything we see around us. These particles combined to form atoms, primarily hydrogen and helium, the simplest and most abundant elements. Within these clouds, stars ignited, fueled by nuclear fusion, releasing tremendous amounts of energy.
From the remnants of supernovae, new stars and planetary systems formed, including our solar system. Earth formed at just the right distance from the Sun to allow for liquid water, essential for life. Life emerged, evolving over billions of years, driven by natural selection. From single-celled organisms to complex life, transforming Earth's atmosphere. Humans with language and culture marked a turning point in Earth's history. We are the universe becoming aware of itself. Made of stardust, we are connected to the cosmos.
To fully grasp the paradox of being nothing and everything, we must embark on a journey of discovery, a journey that will take us to the farthest reaches of the observable universe and deep into the quantum realm, where the very nature of reality becomes uncertain. We will explore the vastness of space with its billions of galaxies, each containing billions of stars, separated by distances so vast that they are measured in light years, the distance light travels in a year. We will marvel at the beauty and diversity of celestial objects, from nebulae, the birthplaces of stars, to black holes, regions of space-time where gravity is so strong that nothing, not even light, can escape. We will delve into the world of quantum mechanics, where particles can exist in multiple states at once, where the act of observation can influence the outcome of an experiment, and where the very fabric of reality seems to be in constant flux. Through this journey, we will come to appreciate the interconnectedness of all things, the delicate balance that sustains life on Earth, and the profound responsibility we have as stewards of our planet.
Our journey will take us from the infinitesimally small to the infinitely large, from the subatomic particles that make up our bodies to the vast cosmic structures that span billions of light years. We will explore the origins of the universe, the formation of stars and galaxies, the evolution of life on Earth, and the emergence of human consciousness. We will examine the fundamental forces that govern the universe, from gravity, the force that holds planets in orbit around stars and stars together in galaxies, to the electromagnetic force, responsible for light, electricity, and magnetism, to the strong and weak nuclear forces, which govern the behavior of atomic nuclei. We will delve into the mysteries of the human brain, the most complex object known to exist in the universe, and explore the nature of consciousness, that elusive quality that allows us to experience the world around us and ponder our own existence. Through it all, we will be guided by the principles of scientific inquiry, observation, experimentation, and the constant search for evidence to support or refute our hypotheses. We will embrace the unknown, acknowledge the limits of our current knowledge, and remain open to new ideas and perspectives.
Our journey through the cosmos will lead us back to the paradox we introduced at the beginning. You are nothing, yet you are everything. We will have seen how, in the grand scheme of the universe, we are but tiny specks, living on a small planet orbiting an average star in an unremarkable galaxy. And yet, We will have also seen how we are integral parts of this vast and wondrous cosmos, connected to everything else in the universe through the shared history of our atoms, the laws of physics, and the grand narrative of cosmic evolution. We will have come to appreciate our own existence as a remarkable and precious gift, a product of billions of years of cosmic and biological evolution. We will have discovered that our significance lies not in our size or our place in the universe, but in our capacity for wonder, our ability to ask questions and seek answers, and our inherent desire to understand the universe and our place within it. We are, after all, the universe becoming aware of itself, and in that awareness lies a profound responsibility and an even more profound opportunity.
Our journey begins with a moment of unimaginable intensity, a moment when the universe as we know it burst forth from a state of unimaginable density and heat, the Big Bang. Picture, if you can, all of space and time compressed into a point smaller than an atom, a singularity where the laws of physics as we understand them break down. In this realm of the infinitesimally small and unimaginably energetic, our universe was born. Then, in an instant, something extraordinary occurred. This point of infinite density began to expand, an expansion that continues to this day, some 13.8 billion years later. This was no ordinary explosion scattering matter outward into a pre-existing space. Rather, it was the very fabric of space itself that stretched and expanded, carrying matter along with it like flotsam on a cosmic tide. As the universe expanded, it cooled rapidly, much like air escaping from a tire loses its heat. In those first fleeting moments, the universe was a seething cauldron of energy, a place where temperatures were so extreme that matter as we know it could not yet exist. Yet within this chaotic inferno, the seeds of our universe were being sown. Section 2. Out of the inferno, the first elements emerge. As the universe continued to expand and cool, a remarkable transformation began to take place. The energy that permeated the early universe began to condense into matter, a process governed by Einstein's famous equation, E equals mc squared, which tells us that energy and matter are fundamentally interchangeable. Out of this cosmic alchemy, the first fundamental particles emerged: quarks, leptons, and bosons, the building blocks of all matter in the universe. These particles, far smaller than atoms, interacted with each other through a primordial soup of forces, a time when gravity, electromagnetism, and the weak and strong nuclear forces were still intertwined. As the universe cooled further, these fundamental particles began to combine, forming the first protons and neutrons, the constituents of atomic nuclei. This process, known as Big Bang nucleosynthesis, occurred within the first few minutes after the Big Bang, a period of intense activity that shaped the future composition of the universe. Section 3. The Dance of Gravity, Sculpting Cosmic Structures. While the early universe was a place of incredible uniformity, tiny fluctuations in density, perhaps remnants of the quantum world from which the universe emerged, began to play a crucial role in shaping its future. Gravity, the ever-present force that draws matter together, began to amplify these fluctuations, pulling in more and more matter wherever these subtle density variations existed. Over vast stretches of time, these regions of slightly higher density grew denser still, pulling in surrounding matter and creating a cosmic web of filaments and voids. Imagine a spider web stretching across the universe, with matter concentrating along the threads of the web and vast empty regions between them. This cosmic web, seeded by those early density fluctuations, would become the scaffolding upon which galaxies and clusters of galaxies would eventually form. The process of gravitational collapse, though driven by a seemingly simple force, is a testament to the elegance and power of the laws of physics. From tiny quantum fluctuations, vast cosmic structures would arise, all governed by the relentless pull of gravity. Section 4. Stellar nurseries, the birthplaces of stars. Within the denser regions of the cosmic web, vast clouds of hydrogen and helium gas, remnants of the Big Bang, began to coalesce under the relentless pull of gravity. These massive clouds, known as nebulae, became the stellar nurseries where the first stars would ignite, bathing the universe in light for the first time. As gravity pulled these clouds of gas inward, they began to spin, much like a figure skater spins faster when they pull their arms inward. This spinning motion further increased the density at the center of the cloud, creating a region of intense pressure and heat. When the temperature and pressure at the core of these collapsing clouds reached a critical threshold, something wondrous occurred. Nuclear fusion ignited. Hydrogen atoms, squeezed together by immense pressure, fuse to form helium, releasing tremendous amounts of energy in the process. These newly ignited stars, far larger and hotter than our own sun, illuminated the surrounding gas clouds, creating breathtaking displays of light and color that we can still observe today in distant nebulae. From chaos to order, the formation of galaxies. As stars ignited within these vast clouds of gas, they exerted their own gravitational pull, drawing together into clusters and eventually into the grand, swirling structures we call galaxies. These islands of stars, each containing billions or even trillions of individual stars, became the fundamental building blocks of the large-scale structure of the universe. The formation of galaxies was a chaotic and complex process involving collisions, mergers, and a delicate interplay between gravity, gas dynamics, and the energy released by stars. Over billions of years, galaxies evolved and diversified, taking on a variety of shapes and sizes, from spiral galaxies with their graceful arms to elliptical galaxies with their smooth, rounded forms. Our own galaxy, the Milky Way, is a barred spiral galaxy, a vast city of stars with a central bar-shaped structure and spiral arms that wind outwards. It's within one of these spiral arms, billions of years after the Milky Way formed, that our own solar system would eventually take shape. A universe teeming with islands of light. As billions of years passed, the universe continued to expand and evolve. Galaxies scattered across the vastness of space became like celestial lighthouses, beacons of energy and matter illuminating the cosmic darkness. Within these galaxies, stars lived and died, their life cycles governed by the laws of physics and the availability of fuel for nuclear fusion. Some stars, much larger than our sun, lived short, brilliant lives, ending their days in spectacular supernova explosions that scattered heavy elements forged in their cores throughout interstellar space. These elements, the building blocks of planets and life itself, would eventually become incorporated into new generations of stars and planetary systems. The universe, once a uniform sea of hydrogen and helium, was becoming increasingly enriched with heavier elements, the products of stellar evolution and cosmic recycling. This ongoing process of star formation, stellar death, and the dispersal of heavy elements set the stage for the emergence of even more complex structures, including planets and, eventually, life itself.
Cosmic time, a journey through eons. To truly comprehend the vastness of the universe, we must stretch our minds to encompass the immense stretches of time involved in its evolution. Consider that our planet, Earth, formed some 4.6 billion years ago, a significant amount of time by human standards. Yet, this is less than a third of the age of the universe itself. When we gaze up at the night sky, we are looking back in time. The light from distant stars and galaxies has taken millions, even billions of years to reach us. The Andromeda Galaxy, our nearest galactic neighbor, appears to us as it was 2.5 million years ago, its light having taken that long to traverse the vast gulf of space between us. Imagine the countless events, the births and deaths of stars, the formation of planets, the evolution of life that have transpired in the vast expanse of time since the Big Bang. The universe is a dynamic and ever-changing place, and we are privileged to witness a snapshot of its grandeur frozen in time by the finite speed of light. In this grand cosmic tapestry, where do we fit in? Our home, planet Earth, is a tiny speck orbiting an average star, our Sun, located in a spiral arm of the Milky Way galaxy. We are made of the same stardust that forms the stars, the planets, and everything else in the universe.
To truly grasp our place in the cosmos, we must confront its sheer immensity, a scale that dwarfs our everyday experiences. The Milky Way, our own island of stars, is just one of billions of galaxies scattered throughout the observable universe. To navigate the vast distances between stars and galaxies, astronomers use a unit of measurement known as the light year. The distance light travels in 1 year. The center of our own galaxy, the Milky Way, is about 26,000 light-years away, while the Andromeda Galaxy, our nearest galactic neighbor, lies about 2.5 million light-years distant.
When we confront the sheer scale of the universe, It is easy to feel a sense of insignificance, even a touch of existential vertigo. Yet it can also be a source of profound humility, reminding us that we are part of something much larger than ourselves.
But is insignificance the only conclusion we can draw from our contemplation of the cosmos? Paradoxically, the very fact that we can comprehend the vastness of the universe speaks to our own significance. We are, after all, the universe becoming aware of itself, capable of studying its own origins, its evolution, and its ultimate fate.
The laws of physics appear to be remarkably fine-tuned for the emergence of life as we know it. If these values were even slightly different, the universe would be a very different place, and life as we know it would likely not exist.
This apparent fine-tuning of the universe for our existence has led some scientists and philosophers to propose the anthropic principle. Is our existence a matter of chance, a fortunate accident in a universe governed by impersonal laws? Or does it point to a deeper meaning or purpose?
As vast and awe-inspiring as the observable universe is, it is likely just a tiny fraction of a much larger, perhaps infinite, cosmos. The universe is a place of endless fascination, filled with mysteries yet to be unraveled.
Our journey through the cosmos now takes us on a detour, a plunge into the bizarre and often counterintuitive world of quantum mechanics. Here, in the realm of the ultra-small, the familiar laws of classical physics break down, replaced by a set of rules that seem strange and even paradoxical. One of the most startling revelations of quantum mechanics is that what we perceive as empty space, the vacuum of the cosmos, is anything but empty. This inherent uncertainty in the quantum world allows for the brief existence of virtual particles, borrowing energy from the vacuum for their fleeting existence before disappearing back into the quantum foam. Perhaps the most mind-boggling aspect of quantum mechanics is the observer effect, the seemingly paradoxical notion that the act of observation can influence the state of a quantum system. This strange behavior has led some physicists to propose that consciousness itself plays a role in collapsing the wave function. Section 6. From the quantum to the cosmic, bridging the scales of existence. Our exploration of the quantum realm has taken us to the very edge of human knowledge, a realm where the familiar rules of classical physics break down and where the nature of reality itself is uncertain. Yet, despite its strangeness, the quantum world is intimately connected to the vast cosmic arena we explored earlier. The very same quantum fluctuations that give rise to virtual particles in the vacuum are thought to have played a crucial role in the very early universe, seeding the density variations that eventually led to the formation of galaxies and clusters of galaxies. The laws of quantum mechanics govern the behavior of the particles that make up stars, planets, and even our own bodies. Understanding the connection between the quantum world and the cosmic realm is one of the greatest challenges facing modern physics. Unifying quantum mechanics with Einstein's general relativity, a theory that describes the universe at its larger scales, remains a holy grail for physicists, a quest to find a single, elegant theory that can explain the universe from the smallest subatomic particles to the largest cosmic structures.
The spark of life, from non-living to living. Our cosmic journey now takes us to a pivotal moment in the history of the universe, when inanimate matter assembled into something entirely new life. The transition from non-living to living remains one of the most profound mysteries in science, captivating philosophers and scientists for centuries. How did complex molecules like proteins and nucleic acids arise from the primordial soup? What sparked the self-replicating processes essential for life? While we don't have all the answers, scientists have made remarkable progress. Section 2. A planet, ripe with possibility, the cradle of life. While the emergence of life required the right ingredients, it also required the right environment, a cradle where those ingredients could come together and interact in ways that allowed life to take hold. Fortunately for us, the early Earth provided just such an environment. Though a far cry from the hospitable planet we know today, the early Earth possessed a unique set of conditions that made it ripe for the emergence of life. Liquid water, essential for life as we know it, was abundant on the early Earth, covering much of its surface. The atmosphere, though lacking the oxygen we breathe today, was rich in other gases such as methane, ammonia, and carbon dioxide, which could have served as raw materials for the synthesis of organic molecules. Volcanic activity, widespread on the early Earth, released heat and gases from the planet's interior, creating a dynamic and chemically rich environment. These volcanoes, along with hydrothermal vents on the ocean floor, provided localized sources of energy and nutrients that may have been crucial for the emergence of life. Section 3. Life's first steps. The emergence of single-celled organisms. Somewhere in the vast expanse of the early Earth's oceans, perhaps in shallow pools of water or near hydrothermal vents, the first self-replicating molecules emerged, marking a pivotal transition in the history of life. These molecules, likely RNA or a similar precursor to DNA, possessed the remarkable ability to copy themselves, using the raw materials available in their environment to create more of themselves. This ability to self-replicate, to pass on genetic information from one generation to the next, is at the very heart of life as we know it. It allowed these early molecules to evolve and diversify, driven by the forces of natural selection, where those molecules that were better adapted to their environment were more likely to survive and reproduce. Over time, these self-replicating molecules became enclosed within membranes, forming the first cells, the basic units of life. These early cells were simple, single-celled organisms, but they possessed the essential machinery for life, the ability to metabolize energy, to grow and reproduce, and to evolve. Section 4. The power of evolution, from simple beginnings to astonishing diversity. From these humble beginnings, the power of evolution, driven by natural selection, mutation, and genetic drift, would weave an extraordinary tapestry of life over billions of years. Single-celled organisms diversified, giving rise to a vast array of prokaryotes, simple cells lacking a nucleus, such as bacteria and archaea, which still populate every corner of our planet. One lineage of these early prokaryotes gave rise to a new type of cell, the eukaryote, a cell with a nucleus containing its genetic material. Eukaryotes, with their more complex internal structures, would eventually give rise to all the multicellular life we see today: plants, animals, fungi, and protists. The evolution of photosynthesis, the process by which organisms use sunlight to convert carbon dioxide and water into sugars and oxygen, marked a major turning point in the history of life. Photosynthesis not only provided a new source of energy for life, but also transformed the Earth's atmosphere, gradually increasing the concentration of oxygen, paving the way for the evolution of oxygen-breathing organisms. Life's grand experiment, the Cambrian explosion and the rise of complex life. About 540 million years ago, life on Earth underwent a remarkable burst of diversification known as the Cambrian explosion. During this relatively short period, geologically speaking, a dazzling array of new body plans and life forms emerged, filling the oceans with creatures of unprecedented complexity. Sponges, jellyfish, worms, arthropods, mollusks, and the first chordates, the ancestors of all vertebrates including ourselves, appeared in the fossil record, showcasing the incredible power of evolution to generate diversity and complexity. The Cambrian explosion was a testament to life's ability to experiment, to explore new ecological niches, and to adapt to changing environments. This burst of diversification was likely driven by a combination of factors, including an increase in atmospheric oxygen, the evolution of new developmental genes that allowed for greater morphological complexity, and an escalating arms race between predators and prey, driving the evolution of new adaptations for survival. The ascent of intelligence, from simple nervous systems to complex brains. As life diversified, so too did its ability to sense and respond to its environment. Simple nervous systems, composed of interconnected neurons, evolved, allowing organisms to detect light, touch, chemicals, and other stimuli, enabling them to navigate their surroundings and find food and mates. Over time, these nervous systems became increasingly complex, evolving into centralized brains in some lineages. particularly in the animal kingdom. These brains, the most complex structures known to exist in the universe, allowed animals to process information from their senses more efficiently, to learn and remember, and to exhibit increasingly sophisticated behaviors. The evolution of intelligence was not a linear progression, but rather a branching tree, with different lineages evolving different types of intelligence suited to their particular ecological niches. From the problem-solving abilities of crows to the social intelligence of primates, brains have proven to be remarkably adaptable organs, capable of evolving to meet the challenges and opportunities presented by a wide range of environments. The human story, a species capable of reflection and wonder. Among the countless branches on the tree of life, one lineage, the hominins, embarked on a unique evolutionary trajectory. Our lineage developed traits that set us apart, most notably our large brains and capacity for language. Our ability for abstract thought, dexterous hands, and upright posture allowed us to manipulate our environment. We developed tools and technologies, spread across the globe, and adapted to various habitats. We became the dominant species, shaping the biosphere. Our most remarkable trait is our capacity for self-reflection, questioning our place in the universe, and pondering our own existence. We marvel at the wonders of the cosmos.
The emergence of consciousness, that elusive quality that allows us to experience the world around us and to reflect on our own existence, remains one of the greatest mysteries in science. How did consciousness arise from the material world? Is it a product of our brains alone? Or is it something more fundamental, perhaps even a property of the universe itself? Some scientists and philosophers believe that consciousness is an emergent property of complex systems, such as the human brain, arising from the intricate interactions of billions of neurons. Others propose that consciousness is a fundamental aspect of reality, a panpsychist view that suggests that even inanimate objects possess a rudimentary form of consciousness. While the nature of consciousness remains a topic of intense debate, there is no denying its profound impact on our understanding of the universe and our place within it. Consciousness allows us to appreciate the beauty of a sunset, the wonder of a starry night, and the intricate workings of a living cell. It allows us to love, to create, to explore, and to strive for something beyond ourselves.
As we reflect on the long and winding road that life has taken, from its humble beginnings in the primordial soup to the emergence of consciousness, we find ourselves at a unique juncture in the history of life on Earth. We are the inheritors of an extraordinary legacy, the product of billions of years of evolution, shaped by the forces of natural selection, chance, and the interconnectedness of all living things. But we are also at a crossroads, facing unprecedented challenges. The choices we make today will determine the course of life on Earth. We have the power to be both destructive and creative. The knowledge we have gained through science, combined with the wisdom we have inherited from generations past, gives us the tools and the responsibility to create a future where both humanity and the natural world can thrive. Our cosmic journey has taken us from the heart of stars to the emergence of life, revealing a universe of astonishing scale and interconnectedness. Now we turn our attention to our home planet, Earth, a world teeming with a staggering diversity of life, all interconnected in a grand, intricate web of relationships. This is the realm of ecosystems, where living organisms interact with each other and their physical environment, creating a delicate balance that sustains life as we know it. Imagine for a moment a vibrant coral reef, a kaleidoscope of colors and shapes, teeming with fish, corals, sponges, and countless other marine creatures. Or picture a lush rainforest, its canopy alive with birdsong, its understory a tangle of vines, ferns, and insects. These are just two examples of the countless ecosystems that blanket our planet, each a unique expression of life's creativity and resilience. From the frigid polar regions to the scorching deserts, from the depths of the oceans to the heights of the mountains, Ecosystems weave a living tapestry across the Earth's surface. Each ecosystem is a complex and dynamic system, shaped by factors such as climate, geology, and the interactions of the species that inhabit it. The web of life, interdependence, and the balance of nature. Species are linked in a web of interdependence, relying on each other for food, shelter, and pollination. Consider the bee and flower, a classic example of mutualism. The bee collects nectar and spreads pollen, aiding plant reproduction. This web is complex, involving predators, prey, and decomposers. Predators and prey balance each other's populations. Herbivores shape plant communities and energy flow. Decomposers recycle nutrients, completing the cycle of life. This balance is delicate and can be disrupted by external forces. Section 3. Ecosystem Services, Nature's Gifts to Humanity. The web of life is not merely a beautiful and awe-inspiring phenomenon, it is also essential for our own survival and well-being. Ecosystems provide a wide range of services that benefit humanity, often referred to as ecosystem services. These services are the foundation of our economies, our societies, and our very existence. Consider the air we breathe, cleansed and replenished by forests and other ecosystems that absorb carbon dioxide and release oxygen through photosynthesis. Or the water we drink, filtered and purified by wetlands and watersheds that act as natural sponges, absorbing excess rainfall and filtering out pollutants. Ecosystems also provide us with food, fuel, medicines, and countless other resources that we rely on daily. The pollination services provided by bees, butterflies, and other pollinators are essential for the production of many fruits, vegetables, and other crops. Forests provide timber for construction, paper, and other products. The natural world is a vast and invaluable library of genetic diversity, holding the potential for new medicines, agricultural innovations, and other technological advancements. Section 4. The Gaia Hypothesis. Is Earth a living organism? The interconnectedness of life on Earth and its profound influence on the planet's systems have led some scientists to propose a radical idea that Earth itself is a living organism. This idea, known as the Gaia Hypothesis, was first put forth by James Lovelock and Lynn Margulis in the 1970s. According to the Gaia Hypothesis, Earth's living organisms, through their interactions with each other and their physical environment, have created a self-regulating system that maintains the conditions necessary for life. This system, like a living organism, maintains homeostasis, a stable internal environment, despite external changes and disturbances. While the Gaia Hypothesis remains a controversial idea, it has sparked a new way of thinking about our planet and our place within it. It emphasizes the interconnectedness of all living things and the profound influence that life has had on Earth's systems, from the atmosphere to the oceans to the very rocks beneath our feet. For billions of years, life on Earth has been shaped by the forces of evolution, adapting to changing environments and forging intricate webs of interdependence. But in recent centuries, a new force has emerged, a force capable of altering the planet's systems at an unprecedented rate and scale: humanity. Our species, with its technological prowess and its insatiable appetite for resources, has left an indelible mark on the planet, transforming landscapes, altering the composition of the atmosphere, and driving countless species to the brink of extinction. From deforestation and habitat fragmentation to pollution and climate change, our actions are disrupting the delicate balance of nature, jeopardizing the very ecosystems that sustain us. The evidence of our impact is all around us, from the plastic pollution that chokes our oceans to the rising sea levels that threaten coastal communities. The sixth mass extinction, a global decline in biodiversity driven by human activities, is well underway, with species disappearing at a rate unseen since the demise of the dinosaurs. Our journey through the cosmos has shown us the interconnectedness of all things, from the smallest subatomic particles to the largest cosmic structures. Life on Earth is a precious phenomenon, shaped by billions of years of evolution. This perspective calls us to understand our place in the universe and our responsibility to our planet. We are stewards entrusted with its care, We have the knowledge and tools to create a future where humanity lives in harmony with nature, ensuring a vibrant Earth for generations to come.
Our cosmic journey has reached its destination, but it leaves us with a thirst for further exploration. We began by pondering a paradox. You are nothing, yet you are everything. This statement has revealed itself as a profound truth, unlocking a deeper understanding of our place in the universe. We have traversed space and time, from the birth of the universe to the emergence of life on Earth, from quantum mechanics to the ecosystems that sustain us.
We delved into the realm of the ultra-small, the quantum realm, where the familiar rules of classical physics break down, replaced by a set of laws that defy our everyday intuition. Here in the world of quarks, leptons, and bosons, we discovered that emptiness is not what it seems. The vacuum of space, far from being a void, seethes with virtual particles, popping in and out of existence. Their fleeting lives are testament to the inherent uncertainty of the quantum world. We encountered the observer effect, a perplexing phenomenon that suggests that the act of observation can influence the state of a quantum system. This notion, still debated by physicists and philosophers alike, hints at a deep connection between consciousness and the material world, a connection that may forever remain shrouded in mystery. The quantum realm, though strange and counterintuitive, is not a separate universe, but the very foundation upon which our macroscopic world is built. The atoms that make up our bodies, the stars that light up the night sky, the very fabric of space and time itself, all are governed by the laws of quantum mechanics.
Our journey through time took us back to the very beginning, the Big Bang, a moment of unimaginable density and heat when our universe burst forth from a singularity smaller than an atom. We witnessed the rapid expansion and cooling of the early universe, the formation of the first elements, and the gradual coalescence of matter under the relentless pull of gravity. We saw how stars, those cosmic furnaces, ignited within vast clouds of gas and dust, forging heavier elements in their cores and scattering them throughout the universe when they reached the end of their lives and exploded as supernovae. We learned that we are, quite literally, stardust, our atoms forged in the hearts of stars that lived and died billions of years ago. From the remnants of these stellar explosions, new generations of stars and planetary systems formed, including our own solar system, a tiny oasis of life in the vastness of the Milky Way galaxy. The universe, once a uniform sea of hydrogen and helium, was becoming increasingly complex, its tapestry woven from threads of stardust, its patterns shaped by the relentless march of time.
As we confronted the immensity of the universe, we experienced a range of emotions, from awe and wonder to a humbling sense of insignificance. The sheer scale of the cosmos, with its billions of galaxies, each containing billions of stars, can make even our planet, with all its teeming life and diverse landscapes, seem like a mere speck in the grand scheme of things. Yet, paradoxically, the very fact that we can comprehend this vastness, that we can develop theories to explain the universe's origins and evolution, speaks to our own unique place within it. We are, as far as we know, the only species on Earth capable of contemplating its own existence, of questioning its place in the cosmos, and of seeking to understand the fundamental laws that govern the universe. In a sense, we are the universe becoming aware of itself, a cosmic mirror reflecting back on itself, seeking to understand its own nature. Our scientific endeavors, driven by curiosity and a thirst for knowledge, are a testament to this inherent drive to understand, to explore, and to push the boundaries of what we know.
Section 5. The paradox embraced humility and wonder in equal measure. The paradox of being nothing and everything is at its core a paradox of perspective. From one vantage point, we are indeed insignificant, our lives fleeting moments in the grand sweep of cosmic time. Embracing this paradox requires holding both perspectives simultaneously. It requires humility, acknowledging our limits, and wonder, appreciating the universe's beauty and complexity. Section 6. A universe of meaning purpose found in exploration and understanding. In a universe that often seems indifferent, it is tempting to succumb to nihilism. Yet our cosmic journey shows us that meaning is created through our actions and pursuit of knowledge. As Carl Sagan said, we are a way for the cosmos to know itself. Our ability to study the universe is a testament to life's extraordinary journey. In our quest for knowledge, we find purpose, not because the universe demands it, but because it is in our nature.
Section 7. A legacy of stardust, a future of our own making. We stand at a pivotal moment in the history of life on Earth, the inheritors of an extraordinary legacy, the product of billions of years of cosmic and biological evolution. We are the descendants of stardust, our very existence a testament to the interconnectedness of all things and the delicate balance of physical laws that allows for life to flourish. Yet we are also a species at a crossroads, facing unprecedented challenges, from climate change and biodiversity loss to the ethical implications of our own technological advancements. The choices we make today will determine not only our own future, but also the fate of countless other species and the health of the planet we call home. We have the power to be both destructive and creative, to degrade our planet or to nurture it, to perpetuate conflict or to strive for peace. The knowledge we have gained through science, combined with the wisdom we have inherited from generations past, gives us the tools and the responsibility to create a future where both humanity and the natural world can thrive.
Section 8. The Cosmic Dance, embracing the mystery and majesty of existence. Our cosmic journey has been a journey of discovery, a journey that has taken us to the farthest reaches of the universe and to the depths of our own being. We have encountered wonders that defy imagination, confronted mysteries that may never be fully solved, and gained a profound appreciation for the interconnectedness of all things. We have learned that the universe is a place of both order and chaos, of elegance and brutality, of beauty and terror. It is a universe that operates according to laws that we are only beginning to understand. Laws that govern the behavior of the smallest subatomic particles and the largest cosmic structures. But perhaps the most important lesson we have learned is that the universe is not a static, unchanging entity, but rather a dynamic, ever-evolving process, a cosmic dance in which we are all participants. From the birth of stars to the emergence of life, from the formation of galaxies to the evolution of consciousness, the universe is in a constant state of flux, a grand and majestic spectacle that continues to unfold before our very eyes. Our journey continues. As we conclude our cosmic journey, we do so not with a sense of finality, but with a renewed sense of wonder and a thirst for further exploration. The universe is vast and mysterious, filled with unanswered questions and endless possibilities for discovery. The journey ahead is ours to shape. We can choose to retreat into our own small worlds, consumed by the mundane and the trivial, or we can choose to embrace the vastness and mystery of the universe, to continue to explore, to question, and to strive for a deeper understanding of our place within it. The choice is ours, but the universe, in all its grandeur and majesty, awaits. Our journey continues. Please like, subscribe, and comment to support our channel. Your engagement helps us continue this journey